People love saying Earth's rotation can't be observed or measured without trusting NASA or giant government organizations. But that's not true. You can actually observe, measure, and even predict Earth's rotation all by yourself, right at home. So let's predict it. We're told Earth rotates once every 24 hours. That means the planet rotates 15 degrees every hour. But a Foucault's pendulum doesn't rotate at 15 degrees an hour unless you're standing right at one of the poles. I'm in Arizona. It's about 33.4 degrees north latitude where I'm at. Using this formula on screen, which is 15 degrees times sine your latitude, we get a predicted precession rate of 8.26 degrees per hour. So with this pendulum that I have set up in my garage, we're going to predict 8.3 degrees per hour drift. So before we even start this experiment, we already know what should happen if we live on a spinning globe. The setup's pretty simple. We got a 10-pound lead anchor, 30-pound SpiderWire fishing line, and a ball swivel. I've got this camera set up recording almost perfectly straight down so that we can measure the motion accurately. One of the biggest problems with a pendulum like this is releasing it. So we've got this little string that we're going to tie up back here, and we're only going to pull this thing back 6 inches. And that way, we don't get extra wobble or anything like that. Okay, so here we go with the release. We'll come back in an hour. So here we go. You can see it's a little blurry. The camera focuses here in a second. In the bottom right, you can see a timer that will go up for an hour. I'm going to time lapse this thing and compress it down to like 20-30 seconds so you can watch it if you want. You can skip ahead if you want. And we'll see what the swing was like at the end of that. It does zoom in as it swings, so we can see that circle with the degrees of angle on it. So there we go, it swung for an hour. We can see that it lines up somewhere around like the 6 to 10 range. It has a little bit of a wobble in it, but it's somewhere between 6 and 10. We're gonna use Photoshop and measure the actual angle by screenshotting the farthest forward and the farthest back swing on the beginning of it and the end of this, and see what we get. Okay, so we've got these in Photoshop, and what we're gonna do is change the opacity of this one down so we can see both of those, and then draw a line pretty much from the center of this one to the center of that one as close as we can. We're going to make this line as thin as possible, and then we're going to do that with the second set. So we'll turn the opacity down. Let's see, it's about right here. See if we can get this thing about there. And now we're going to zoom in a little bit more. Not that much. Go back to here. Okay. We'll grab our ruler tool and click as close to the center of the line as we can. This is bouncing back and forth on each side of this line, so this one's a little harder. Then we hold Alt and go to that. So it looks like we got 13.7 degrees of precession after 1 hour. Now realistically, testing this multiple times is the proper way to get solid scientific results, but I don't really have time to run this experiment over and over again over the next couple of weeks. And looking at the footage here, you can see that the pendulum developed wobble over time. That can happen for a few different reasons. The release may not have been perfectly clean. The fishing line may have had a slight twist in it still. Air currents in the garage affecting the swing. And an anchor is not exactly the most precise, balanced pendulum. But even with the wobble, we can still clearly see that the swing plane changed relative to the floor over the course of an hour. And that's the important part. This isn't some CGI animation or computer simulation. It's a 10-pound anchor hanging in my garage. Now I challenge anyone else to try and do this experiment yourself.